Okay, so here is the zero DFD. I'm just using an example. There is a customer user. Customer provides an order. A process named process customer order takes that order and does whatever needs to be done to store the order details in an order file or an order data store, and then strips the order of the customer detail and stores it in a customer data store. This process, and if you notice, it is working independently. There is no connection between these two, which is fine. Sometimes there is, sometimes there is not. So if there's a connection, that basically means process 1 is triggering process 2. But in this case, we are saying this is working independently. So the second process, process payment, is taking payment from the customer and then recording the processed payment into the file, the payments data store. But to actually process a payment, it needs to get some order details. So these are the order details. If you notice, they're coming from the orders data store, right from there. And once the payments are processed, it is basically generating a receipt and giving the receipt. Okay. So taking this zero DFD, I'll show you how to break it down and what you should be looking for ideally in the next DFD, which is the child DFD. So now child DFD, what happens is, once you have the understanding of this level of the system, you go deeper, and what you do is you break the processes one by one. Okay. So the principle is, next stage of breaking down, you will get one separate diagram for the child of one processes, and you will get another separate diagram for child of two. You don't mix them anymore. You actually start separating them. The reason is to keep it simple. Otherwise, it just gets too complicated. So the child of one processes would be numbered as 1.1, 1.2, 1.3, so on and so forth. And the children of process 2 would be labeled as 2.1, 2.2, 2.3, so on and so forth. Okay, so let's see how we break it down. So the idea is quite simple. The idea is to only show one part of the system. Okay. So if you notice up here, the process customer order is the one we are trying to break first. Okay. Now, to process a customer order, just by looking at the data flows, you can see it does two things. One is it processes customer order details and then processes customer details. So basically, if I break this process down, you will get to see two processes inside, which is 1.1 and 1.2. So let me just try. Process 1.1, process 1.2. So as we can see, it is what it's doing. It's breaking. So I'll just name these processes. I'm saying the first child of 1 or 1.1 is process order details, and 1.2 is process customer details. Now the trick is quite simply to make sure that your focus is this process. You're showing what's inside it, so what's outside doesn't change. So if you notice, this process is linked to the entity customer. So now here you can either draw that, or some people can just show the data flow order coming in. Both are fine. Okay. So I'll draw that, but don't worry. If students don't show that, that's fine. So first let me do it without showing it so that you understand that. So the order is coming into process 1, but which part of process 1 will it go in? Will it go in process 1.1 or 1.2? So if you can see, that's where the processes are ordered. So let me just draw that. So from the outside, your orders are coming in. And this data flow has to be the same as the data flow at the top level. What you are getting inside is what you're getting inside. So the same thing comes in. But this process, what it does, it strips the order details. So if you notice, strips the order details and store the order details. And the second process stores the customer details. in this process, sorry. Okay. So, so it's not complete yet. I'm just trying to. So basically, if you look at this, if I enclose these in a circle, these two are basically nothing but put together they're process number 1. Okay. Getting the order, stripping the order of the order details and stripping them of customer details. But now what you'll be looking out for is something like this. Now this is something called, as you already know, it's called a miracle process or spontaneous process, which has no input but only has output. Okay, that's wrong. So to get the customer details, we still need the order. So what students can do, and it's allowed to show the same data flow twice, and it's fine. They can either show it like this, which basically says the same thing is going into 2 locations, or basically they can show it as 2 orders, which is fine. They're just saying it's the same thing. So now it's complete. So I'll just draw a dotted line just to show you what I mean. So if you now look, this dotted line is basically nothing but a representation of process 1, which gets order details and then stores into orders and stores into customer, which is exactly the same. We're just showing you a bit more details, saying process order detail and then process customer detail. Both of these processes are sub-processes of process 1. Okay. So that is basically what a child diagram is breaking down. What you have to look for is, have they by mistake changed the names of the data flow? Order should be the same. That's balancing. Have they changed the output somehow? So output must be exactly the same. And another thing you have to check is, for the child of 1, there should only be 1.1, 1.2. By mistake, some students might put a different child process like 2.1 or 3.1, which is wrong. They cannot stay in the same diagram. They have to be different diagram. The other things which will be variable, some people will show the external entity and some will not, which is fine. So for example, orders are coming from customer. Some say orders are coming from customer without showing the external entity. Why? We have already shown it in a higher diagram. Others will repeat it, which is fine. Okay, so I can draw that here. Okay. So be a lookout for these things, that the child of diagrams, by the way, they have to draw the child for process 2 and process 3. So keep a lookout of these things, that the data flows match the data flows at the 0 diagram level. Sometimes they might break them, but they'll have to write assumptions, why they break it and how they broke it. So keep an eye on the data flows. Second, make sure the processes are labeled the same. A child of 1, child of 2. Okay. So some people will show process 1, process 1.1. No, that's wrong. You cannot have the parent 1 and the child 1.1 at the same level. If you're showing children, you can only show children, child processes. So the other things that you have to make sure are the same things that we have done for the normal DFDs. Make sure there are no black hole processes. You understand black hole, which is basically a process with inputs but no outputs. This is wrong. If there is an input, there must be an output. Look out for spontaneous generation or miracle process, which is the opposite, which is the outputs but no inputs. Another one is gray hole, which is very difficult to find, which basically means the input, whatever is going in, is not sufficient to produce what is coming out. So basically things like just by taking customer today's date, you cannot produce somebody's date of birth, oh sorry, age. For age, you also need somebody's date of birth. Okay, so this is a logical error. Don't worry about it too much. Okay. The other thing you have to make sure you remember is things like this. The data flow must have a verb naming, must not have, sorry. So data flow must not have a verb naming. It is not allowed. So for example, data flows like get name, get marks is not allowed. It should just be marks, name, as in what is flowing. The other thing you have to be careful of is data flows must be moved by a process. That means a data flow coming from an external entity like customer going to a data store is wrong. It cannot move by itself. There has to be a process. Or and from data store to a data store. That is wrong. Okay. Or different combinations, as I said. So the data flow must always have either a process on its back end, if you like, or on the front end. It must be moved by a process, otherwise it's illegal. Okay. And lastly, what you have to make sure is double-sided arrows. Okay. Now, double-sided arrows are fine. The only place they are fine is when a process is talking to a data store. So if somebody wants to say there's a read-write going on, a lot of read-write, they can show a double-sided arrow, which is okay. But if they show a double-sided arrow anywhere else, so for example here, that's wrong. So any process talking to a data store can be double-sided, saying for me to read something, I have to write something, and so on and so forth. That's fine. Okay, I hope I explained this well. If you have any questions, let me know, and I can record a follow-up. Okay, so I'll just keep these in front so that you can probably draw them. I'm really sorry for this hurried work, but otherwise I won't be able to do it. Okay, good luck. Ask us questions if you like. Thanks, Manu. Take care.